Okay, so remember the procedure. Please have all the details correct, meaning make sure the open side is the right. Make sure you peeled off any fringe or stuff from your paper. Jerome will come and pick it up. As he's getting that, I'm going to make some announcements, so if you can do that, hand those in quietly. Do you have a way you want to do that?
Do you have what?
Do you want them to separate Friday and Monday?
No.
Okay.
I'll just separate. Do you guys have your...
Okay, so draw your attention to, I want to remind you that there's this PSA 21 is a help room designed specifically for this course. So the tutors that are in there, they've been trained in this curriculum, as we know is very different than a traditional math class, okay? So take advantage of that. I have my normal office hours in my office, but then I also spend 1 hour there on Tuesday morning from 10 to 11, okay, just so you know. And then Jerome's office hours are actually all in that room, okay? So PSA 21, Tuesdays and Thursdays 4:30 to 6. So you can just go and do your homework there. And you can go anytime, so it's open like Monday through Thursday, 9 to 6, and Friday, something like 9 to 1. Okay, so you can go anytime. But if you want to find us, this is how you can find us there. Let's see. So yeah, you can just go and just work on your homework. If you don't have any questions, just pack up and go. Or you can bring specific questions, however you want to make use of it. Okay. So don't be afraid to try that out. Okay, because that's going to be your best bet for help in this class. The other thing is there were a few people that could not make it because of the flooding on Monday, and if you had recitation on Monday and you didn't make it, you can take the quiz right after class today. Okay, just during passing period. So we can stay here. Jerome's got some copies. So if you missed the quiz Monday, you can take it after class today. Questions about stuff? Any administrative details? Our first exam is going to be a week from this Friday in recitation, or the following Monday in recitation. So we're about just a little over a week out from the first exam. Okay? We'll talk more about that as it gets closer. Okay, so last time we talked about this open top box question, and when you get a chance, Jerome, I think it's just the third button. Just click the third button. This open top box is really a conversation that's in the realm of what we call functions, okay? Functions. So the open top box is a context for what we call input-output relationships. Input-output relationships. For example, if the input was the length of the square cutout, right, we could vary that, right? We could choose different size square cutouts. If we think of that as the input, one possible relationship would be think of the volume of the resulting box as the output corresponding to the input. Okay? So the question is, though, not some input-output relationships we call functions, but not all. Okay? So just because it's an input-output relationship doesn't necessarily mean it's a function. So we're going to take some time to understand what is it exactly that we mean when we say a function. Okay? So what is it that makes an input-output relationship a function? So let's consider making a call with your I should have smartphone now, right? So it's with your smartphone, okay? What's the input when you make a call? The phone number, right? The phone number. So here's some possibilities, okay? So all inputs forms a set, okay? All input forms a set of input values. What's the output? A person or a place, right? So like a person or a place. Your X. Okay. Here we go. So how does your phone and service function properly? How does it work? What's a proper function? Every time you dial this number, you want to get this recipient, right? Every time you dial this number, you want to get, say, your friend. Okay, so this is a functioning phone, right? This is a functioning phone. It works. Okay? So the idea is that for each input, the function has a single output. A single output. For each input, there's a single output. That's the idea. That's what makes it a functioning phone. Okay, but what if, say when you dial this number, sometimes you get your mom and sometimes you get the pizza delivery. Or if you dial this number, sometimes you get your brother, sometimes you get your ex. Yeah, right, exactly. So what are you going to do with this phone? You're going to get a new one, right? This phone doesn't work. It's not performing its valid function. Because why? Because the same input is giving different outputs. You see? It's not functioning correctly. Okay, what about this? So suppose your friend has two phone numbers. So room phone, smartphone. Do you even have room phones anymore? Like someone does. Okay, so maybe he has his smartphone and a secret cell phone, okay? Or something like this, right? So your friend has two numbers. We know that these like companies, these customer service, there's lots of different numbers you can call to get customer service for a company. All right, what about this situation? Is your phone functioning correctly? Yes. Sure. Is it a valid function? Yeah. Because, why? Every input still results in one output. That's the key. You could get the same output for different inputs. That's not the criteria. The criteria is when you pick an input, you get just one output. And this is fine, right? And the phone works. The phone is fine. Okay, another example. So suppose one day you and a friend visit a lake on several different evenings, one summer, and you take data regarding temperature, frogs, and crickets. At the end of the summer, you organize your data and you get these graphs. So on the horizontal axis, you're counting rivets of frogs and you're counting chirps of the crickets, and then you're finding out what the temperature is. And so here's the data that you got. These points were the data that you took. So for an input of 2, you got a temperature on a data point of 78. For a temperature of, or input, number of rivets of 3, on one occasion you got 66 degrees, another occasion you got 90. Here's the, when you counted 3 rivets, one time you got 66 degrees, another time you got 91 degrees. When you heard 4 rivets, at one time it was 57, another time 73, another time 84. Similarly, 5. Okay? Is it a function? Yes. For each input, are we getting just one output? No. Sometimes we get multiple outputs for the same input. No, it's not. Okay? What about this? So the crickets, 92 chirps corresponded to 58 degrees. 94 chirps, you got 70 degrees. You counted 97 chirps, it was 82. You counted 100, it was 97. How about this one? Yes. Yes. Okay. So the question is, who are you going to listen to predict the temperature? Obviously, you're going to listen to crickets, right? Frogs is not telling you anything. Crickets is telling something you. It's useful, right? It's useful. So when you have this relationship of one input gives one output, it's something we can use. It's something that's helpful. Rivets aren't helpful for determining temperature. So one unique output for each input means that a function is performing a function. It's performing, it's doing something. Okay, so let's practice that in your workbook. Module 3, Investigation 2. Should look like this. So first of all, some language, okay? Some language. P, what page is that? 83? 83, page 83. So here's some terminology. When we say P is a function of S, it's, you know, this language is a function of really means like is dependent on, right? Is dependent on. So is output dependent on input, or is input dependent on output? Output is dependent on input. So when we say P is a function of S, where P is referring to the output, and S is referring to the input, because output depends on input. You start with input, whatever the input is, you get a corresponding output. So output depends on input is how you can remember which is which when you have these phrases. So P is a function of S, means P is the output and S is the input. Okay? Same with P in terms of S. P in terms of S means that so remember, P in terms of S would be like, it was like where we talked about writing formulas, right? So P equals 3S squared plus 1. That's P in terms of S, right? So what's the input and what's the output? What's the input? S, and then P is in terms of that, so you get an output of P. So P in terms of S likewise means that P is the output, S is the input. So I'm taking time to do this because when students get into problems, and this is the language in the setup, you have to correctly identify input or output, or else you won't be able to make headway. And that it causes lots of confusion if you haven't nailed down what is the input and what is the output. So you got to take these phrases first and really consolidate in your mind, okay, this is the one that's the input and this is the output. So P with respect to S, same thing. P is the output, S is the input. Now, what this doesn't mean is the first thing is always the output and the second thing is always the input. I can say, given S, this function determines P, right? And S, so given S, this function determines P. Well, now S is the input and P is the output, okay? So you just have to read it and understand. But these particular phrases have these meanings for output and input. So I want you to work through, this is numbers 1 through 4. I'm going to start taking attendance on this page. And you're just looking at these relationships of quantities, real-world quantities, and determining, is that relationship, does it meet the criteria for a function or not? Okay, so start working 1 through 4 on this worksheet. Okay, you can talk amongst yourselves. Jerome can come around and help. How do you make it go back down again? Do you know?
Is it not working?
I don't know how you make it go back down.
You're gonna sit in it.
Sit in it?
Yeah, sit on it and then push the lever. Is it not?
I was too far forward. So let's, yeah, okay, we can go through them all fast. Okay, first, number 1. What's the input if we want volume as a function in terms of length of side? Input is length of side. Output is function. We're asking the question, do you get just one what? For this one, though. But do we get just one volume for every side cut that you make? Yes, it's a function. Other way around. Side length in terms of volume. Input is volume. Output is length. Is it a function? Yes. Some are saying yes, some are saying no. So do you remember this from last time? This was our graph of cut out side length as on the horizontal and volume on the vertical. So here I am and I want to pick, you said the input was volume, right? So I want to pick 30. Because I'm on a different thing, that's what it is. Okay, now. Okay, so I'm going to pick 35 as a volume input, right? In this relationship, input. Is there one cutout side length for that volume? No, there's a small square I can cut to get that volume here to make kind of a real shallow wide box. But then there's a much larger side cutout I can make to get a tall, skinny box. They have the same volume. So there's two different cutouts I can make to get that, to achieve that same volume of 35 cubic inches. So if volume's your input and cutout side length's your output, that's not a function. Do you see it? Okay, percentage grade on a test in terms of letter grade earned. Input is letter grade. Output, percentage grade. Function? No, right? Because if you got a B or even a B plus on your test, that could be 87, that could be 88, right? Other way around, if the input is the percentage grade and the output is letter grade, is that a function?
Yes.
Yes. Average monthly rainfall with respect to number of months since January 1st. What's the input? Average monthly rainfall with respect to number of months. Number of months is the input. Okay? So that's this first number of months is what they've called the variable t. And so then the output, of course, is amount of rainfall. Is it a function? Is this a function? If the input is the time, number of months, and the output is the rainfall, is it a function?
Yes.
What's the criteria for a function? For every input, you get one output. Is it true? Yes, it's true. Remember we said, so remember with your phone, multiple numbers could call the same thing, the same person or place, and that's okay. It's a functioning phone because that place has more than one number that reaches it. Okay? So yes, even though there was 1.1 inches average, 1.1 average inches, and in 2 months there was the same average monthly rainfall, it's okay because the input is just pointing at one output in all cases. So do you see that this is a function? It's okay. All right, so let's talk about how we represent these. Okay, so how do we represent functions with notation? Okay, so here's a setup. The distance a motorcycle travels from the intersection in miles is a function of the time elapsed since leaving the intersection in minutes. Would you agree with that statement, that that is a function? What's the output? What's the output? The distance from the intersection. It's claiming it's a function of the time elapsed since leaving the intersection. As the input, is it a function? What if the motorcycle goes and then for a while and then stops? And it's just waiting there. Still a function?
Yes.
For every point in time, there's one distance away from the intersection. What if the motorcycle goes in reverse and then stops? It's still okay. For every point in time, you have one particular distance. Okay, so I'm going to put this on the screen, and when you see that, what came to mind when that appeared from your past experience? What? Just think. Everyone think to yourself. What came to mind when you saw that? Okay, so it would be an interesting conversation to hear your responses, okay? We don't have time. So whatever you thought, I suspect some things, okay, and that's what I'm going to address. But whatever you thought, our goal is to kind of move toward move toward a similar type of thinking about this, okay? That we want to conceive this as three things in harmony together, okay? That 8.3 is the input, and in this case, the number of minutes, right? Number of minutes. So 8.3 is the input into a function whose name is g. So g is the name of this relationship. G is the name of this input-output relationship. And finally, the whole expression is the output. And then that's the number of miles in this case. Number of miles from the intersection. Okay, so g of 8.3 is not a command to do something. And this is what I suspect lots of you thought when you saw that. What do you think? What do I mean by that? A command to do what?
To replace whatever variable you have in there with 8.3.
Right. To take 8.3 and plug it into some formula and crank something out. Okay? So if we wanted to know this distance, yes. If we wanted to get the value, we would take 8.3 and we would calculate the value if we had a formula for it. Okay? But g of 8.3 is not the command to do it. G of 8.3 just represents this number of miles, this output. Okay? So can we write one coherent statement that defines what g of 8.3 is? Given we've got these three things together, essentially, what's the bottom line? What is g of 8.3? So first and foremost, it's what? The number of miles traveled from the intersection, or the output, right? So first and foremost, that whole expression, g of 8.3 is the output. It's the output of the relationship named g when the input is 8.3. So it's not just any output. It's the output of this relationship named g. And it's not just any output of g. Specifically, it's the output of g when the input is 8.3. So rather than seeing it as, oh, I'm going to plug and chug, because we might not necessarily do that. We can just use that to we represent what that output value is. Okay, so here, a function is defined as f of x equals 3x squared plus 8x minus 17. I want to put that up there. What does it mean? Say it again?
What is the value of the output when the input is 2?
He's saying it's the value of the output when the input is 2. Okay? But there may be a transitionary period for many of you, because when you saw that, you just thought, oh, I'm going to plug 2 and get a number, right? But is the general meaning of f of 2 the same or different than the general meaning of g of 8.3 in the previous example? It's the same general meaning. Even though now you have this formula to find that value, it's still the same general meaning. What does it mean? It means 2 is the input, the value of some quantity, into a function whose name is f, resulting in an output of f of 2, the value of some other quantity. So if we wanted to make one concise statement, everyone see if you can write it down. F of 2 is what? So write a concise statement. F of 2 is what? Ashley, what do you think? What do you put? F2 is? the output value when the input is 2. What do you think? Did you get it? Yeah, and we could be a little more specific. We say the output of the relationship named f when the input is 2. Now, what if we wanted to find that value? So we're going to use the rule. This formula is going to tell us what that output value is. I think it's 11. So 11? 12 plus 16 minus 17, whatever that is. 11, okay? So do you see that subtle difference? F of 2 is representing a number. It's not telling you necessarily to do something. But it means something. It means something. It means this output value. Okay, so this idea of a function. So let's go to that function of the input is the side square cutout, and the output is the volume of the resulting box, okay? We said that was a function, right? For every one square cutout, for every square cutout that you pick, you just get one volume, right? So length of the side cutout x was what? Input or output? Input. So you can think of this as like a machine. This function is gonna do something. It's gonna take inputs and give outputs. So we're gonna put this length of side of the cutout in, and we found this rule or this formula to calculate the corresponding volume. So that's what the machine does, and then it outputs volume. So you can think of a function as a process or a machine that's taking input and assigning it to output according to some rule. The rule could be algebraic, but it doesn't have to be. For instance, the input could be all the people in this room. So the domain would be, or the input could be any person in this room, and the output could be height. Is it a function? Does every person have exactly one height? Yes, right? So every person in here has a height. Is there an algebraic rule for that function? So even if we use, say, your student ID number. So input student ID number, output height. Is there an algebraic rule for that? No. There's nothing. But it's still a valid function. Still a valid function. Okay? So we can still think of that as a machine, even though there's no algebra that we do on student ID numbers to get the corresponding height. It's still thought of as a machine because what is that machine doing? It's taking the ID number and giving height, right? It's giving the corresponding height. Okay, let's talk about the notation. So we've got, this is called a function definition. Get rid of this. No, that's not what it was. Okay, so we said that f is the name of the function, okay? And the output of this function is volume. And the input was the length of the cutout. Jeez, what happened? And then if there's some algebraic formula that gives us output, that's called the rule. Okay, so what if I put a circle right around this thing right here? What does that red, what did I just circle? What does that represent? What is that? Tell the person next to you. So what I put a circle around right there, the red circle. Tell the person next to you. What does that represent? What is that? Let's see. How about TJ way back there? What do you think, TJ? So I put a circle around f of x. What does that mean, f of x? It's the input. It represents the input. Let's see, who else do I know here? Wyatt. You agree with that? F of x represents the input. No. Okay, so but the whole thing, f of x means?
I would say that either represent output, could represent the function itself, or could represent the rule.
Okay, so he's saying it could be the output, it could be the function, and it could be the rule. Let's hear someone else. Tell me your name again. Adam. Of x. He says the output of this function f when the input is x. According to what we talked about, that's it. This is the output of f when the input is x. That's what that thing is. The output of f when the input is x. F by itself is the name of the relationship. Okay? X by itself is the input. But that whole expression, f of x, that's the output. And so in this case, in this particular scenario, what is that? F of x then? What does it mean? What is the output of this function f? Volume, right? Volume. This will give you a volume when you make a square setup. When you cut the side at x, right? When you cut the side to be length x. Okay, so let's practice this. I want you to practice what do these things mean. Okay, so talk through, I've written 4 expressions up there. Give the precise meaning of each of those 4 expressions, the precise meaning. Go, so talk those through. Oh, I got all their names here. See, never learned anyone. Okay, is it Benry? You're Benry over here. Benry, okay, tell me. F of 4. What does it mean? F of 4. When the input's 4, the output of f is 4. Do you agree with that? Tell me your name again. Jennifer? He said when the input is 4, the output of f is 4. Is that what f of 4 is? She said the output of f when the input is 4. F of 4 is the output. It's the output of what? Of the function f when the input is 4. So this is the volume of the box when the square cut outside length is 4. All right, next one, f of a. Eric.
The output of f when the input is a.
The output of f when the input is a. So the output of what? Of any function? Okay. So output of f when the input is a. Someone else. Mitchell? Mitchell, I got it. Okay, next one. F of b plus 4.
The output of the relationship f when the input is b plus 4.
Okay. The output of the relationship f when the input is b plus 4. And then what about this next one? I've got to learn names here. Walter.
The output of the relationship named f when the input is b.
Okay. So what is the plus 4? We're adding 4 what? So it would be inches. We're making the cutout longer, or are we adding 4 cubic inches to the volume? You'd be adding 4 cubic inches to the volume. So this would be the volume of the box when you cut out a side length of b plus 4 more cubic inches, right? As opposed to, what's the third one there? We take the side cutout of b and we cut it 4 inches longer, which doesn't make sense if you've got the, anyway. But yeah, it's like you're cutting the square cutout 4 inches longer and then finding the resulting volume. See the difference? Okay, so I got more practice here for you. Okay, so you're driving from Chicago to Kansas City. 4.5 hours after you leave Chicago, you reach St. Louis. 7 hours and 45 minutes after leaving Chicago, you reach Kansas City. So we want to create a function named g that gives the distance driven since leaving Chicago in miles. And that's, we're assigning that the variable d. With respect to the time in minutes elapsed after leaving St. Louis t. So, do we have an algebraic rule for this? Do we have an algebraic rule for your distance after time t? This is a true, like an actual real situation, a road trip. Is there an algebraic rule that you could have? Not easy, right? So if there was one, it sure wouldn't be easy, right? Because when you're driving a long road trip, I mean, there's so many variables involved, right? In terms of turning and speeding up and slowing down. So we don't really have a rule here, but we can still talk about this function, this relationship between distance and time. We can define that function, and then we can talk about the function notation. So I want you to work through questions A, B, and C. So a domain. We didn't talk about that yet. So domain, the idea of domain is all possible inputs into the function. So in this case, in a real-world scenario, it's going to restrict what inputs make sense and what inputs don't, right? So when we talked about the box last time, we said you can't cut a negative side length, right? And then there was a limit to how big we could cut that square so that we could still cut 4 squares out, right? So that range of values for side length was the domain, possible input values. Okay, so give this a shot here. So work on this. You can work together. We'll come around and help. Lots of this stuff on your quiz. Coming up. You're not coming up with a rule for part A. You're just writing function notation. That's correct. Because the input is G, the function is G, output G of T, is correct. D with respect to time, right? So D with respect to T means D is the output, T is the input. So if we're going to name the function G, it's going to be G of T. Give you T. You're good? Any better? Is it better? Okay, so you should have gotten for part A, G of what? T. And that's the same as? So I'll put it on this side, because it's not, D isn't the rule, it's just the variable. So you could say D equals G of T. Because the input is T, and so then G of T would be the output, and we know that's the same as our, what we called our variable D. Okay, what's the domain? So if you notice, time in minutes since after leaving St. Louis, did you notice that? So what are possible, all possible values of time that make sense here? Starting at what? 0. How about T equals 0? Does it make sense? Sure. It's just the moment you start the clock and you haven't started driving it, or you haven't left, you're at St. Louis, right? You're at St. Louis, you're just about to leave, you start the clock, T equals 0, okay? What's the largest possible time here? 7 hours, 45 minutes, is that right? No, because that was the time from Chicago to Kansas City. So this is 7.75, right? Hours. So if it's the time since leaving St. Louis, the maximum time to get to Kansas City, 3.25 hours. Did you catch it? Because those times are both referencing how long it took you from Chicago. This function, T, is starting the clock in St. Louis. So the maximum value of T is when you reach Kansas City, which is 3.25 hours after you leave St. Louis. Okay, so we don't have time for these. What's the price? So I'll post the new quiz for Friday and Monday, and then you have web work for Friday. Okay?